Math 1332, Chapter 10, Probability and Counting Techniques, Section 1, Basic Concepts of Probability, Video 1, The Essence of Probability, Essential Terms. This video is dedicated to the memory of Bojangles the Hedgehog, who made a cameo appearance in an earlier video in this series. R.I.P. Bo, 6/17/21. Gonna miss you, buddy. So what is probability? Believe it or not, you probably already have an intuitive feeling for the concept of probability. I'm going to convince you with the following three scenarios. Number one, the weather person on the news says there's a 70% chance of rain tomorrow. So you set your umbrella by your front door as a reminder to take it with you. Scenario number two, you don't play the lottery because your chances of winning are practically zero. Number three, you and a friend are trying to decide who pays for dinner. You suggest flipping a coin, but your friend suggests playing rock, paper, scissors. Now, what the heck do these have to do with probability? The first one may seem a little bit obvious, and maybe the second one as well, but there's an implied use of probability in the third one, which I'll explain here in just a moment. All of these scenarios involve probability in some way. Loosely speaking, probability is the percent of the time you expect something to happen. Now, calculating, that's another story, but that's one way to think of probability. We're going to define it more rigorously in the videos to come. But here's how probability is involved with all three of the preceding scenarios. When a weather person on the news says there's a 70% chance of rain tomorrow, that means based on past data, under similar conditions, it rained about 70% of the time. Excuse me. Concerning the lottery, if you buy a Powerball ticket, and these are the correct numbers, by the way, if you buy a Powerball ticket, you have a 1 out of 292,201,338 chance of winning the jackpot. This is about a 0.000003% chance of winning. Again, these are the correct numbers, and I kind of wonder where that 292 million number comes from before the end of this chapter. You'll not only know, but you'll understand how. Well, that's the plan. And number three, your friend knows you has, oh gosh, you know I can't stand my grammatical errors. Your friend knows you have a 50% chance of paying for dinner if you flip a coin. But he can read you like a book and consistently beats you at rock, paper, scissors. He figures his chances are better of you paying for dinner if you play. In order to adequately discuss probability, we need to define a few terms first. I've got them all here already, not covered up. The first term is a probability experiment. That is a process that produces one of several possible well-defined results. Oh, these typos are killing me. For example, you could roll a die and look at the number on top. You could draw a card and tell me which card it is. You could flip a coin and tell me if it's heads or tails. You could pull a ball out of a bag of balls and tell me what color it is. You could pick a letter at random from the alphabet and tell me what it is. But it's an experiment that produces a single result out of several possible well-defined results, meaning that you know whether or not something will be a result. For example, if I say pick a letter of the alphabet, I know that you could say W, and I know that you shouldn't say tomato. An outcome is the result of a single trial of a probability experiment. So it's one of the, if you think of a probability experiment as a question, roll a die, what number did you get? Draw a card, what number did you get? Pick a letter, what letter did you pick? Then an outcome is a possible answer to that question. An event is a set of possible outcomes of a probability experiment. For example, if you're picking a letter, then the event could be you pick a vowel. Or if you roll a die, then the event could be you roll an odd number, something like that. Note that the set can be empty. For example, if you roll a die and the event is you get a number with 2 digits, but you won't, that set is empty. A sample space is the set of all possible outcomes of a sample space, of a probability experiment. If you think of a probability experiment as a question, what number did you roll? What letter did you pick? An outcome is a single possible answer. An event is a collection of answers, and it may be an empty collection, but the sample space is every possible answer you could get. Pick a letter, sample space, A, B, C, D, all the way through Z. Roll a die, sample space, 1, 2, 3, 4, 5, 6. Draw a card. Tell me what suit it is. The sample space is hearts, diamonds, clubs, and spades. When we define theoretical probability in the next video, we will rely on all of these terms. And I believe that statement is also at the bottom of the next page. It is. It's hidden down here, so we'll go ahead and uncover it. Forgot to delete it when I did some copy, pasting, and changing. But here's a quick example of all 4 terms in terms of rolling a standard 6-sided die. I'm assuming most of you are familiar with what a die is. You may be more familiar with the plural, which is dice. When you roll a pair of dice, technically speaking, a die is a cube with the numbers 1, 2, 3, 4, 5, and 6 on them. Although they don't have to have those numbers, that's a standard 6-sided die. Roll it, and a number comes up 1 through 6. The act of rolling the die and noting the number is the probability experiment. Remember, it's like the question, what number did you get? The experiment has 6 possible outcomes. 1, 2, 3, 4, 5, and 6. There are several events you could define, such as rolling at least a 4. Well, if you needed to roll at least a 4, what numbers are you looking for? 4, 5, and 6. And remember that an event is technically a set, which is why it's in braces. You thought set theory was going away forever. Rolling a multiple of 3. Well, here's the sample space right here. I'll highlight it just so you can find it easily. If the event is rolling a multiple of 3, which of those numbers would be in that event? Which outcomes would be in that event? Only 2 outcomes, 3 and 6. So those are the only numbers on a standard 6-sided die that are divisible by 3. Rolling a number less than 7. Which numbers on the die are less than 7? Well, all of them. Rolling a number greater than 7. Well, which numbers on the die are greater than 7? None of them. The empty set. What's the sample space for the experiment? Well, it's kind of already on this page twice, but it's the set containing 1, 2, 3, 4, 5, and 6. Now, the thing highlighted in yellow is technically the sample space, but when we were looking at that, we weren't looking at it as a collection of outcomes. We were looking at it as 6 individual entities. So we're looking at it in terms of its parts, not in terms of the whole thing. But you may notice that the sample space did occur right here. Excuse me, let's highlight it. When the event was rolling a number greater than 7. And by the way, I should clarify that when you define an event, there doesn't have to be some characteristic that says, oh, this describes all the numbers in there. For example, I could just pick some numbers at random, 1, 2, 4, and 6, and call that the event. What do those numbers have in common? Honestly, doesn't matter, because all you have to do to be an event is to be a collection of outcomes for the probability experiment. If you want to think of it in terms of set theory, all an event is a subset of the sample space. Let me say that again. All an event is any subset of the sample space, which could include the entire sample space itself, or it could be the empty set. What do we have underneath there? Oh, I know exactly what's underneath this little white box here. It says, notice the sample space can also be thought of as an event. Thought of as an event. When we define theoretical probability in the next video, we will rely on all of these terms. Oh, that's the end of this video.